Good morning again, and here is the next video that I am making for you to help you with the Parks testing for this week and stuff that I would wanted to cover. So I hope that you watch this. So it's arc length formula. Now in the previous video we did some conversions from radians to degrees and degrees to radians. And by the way, I know I made a couple of vocab errors when I was speaking. I was a little nervous, so just bear with me. So arc length formula, we're going to be talking about degrees and radians together. And we need to know that an arc is part of the circumference. And circumference is the perimeter of a circle, which means it's the outline of a circle. Okay? So you should write this stuff down in your notes. Okay, the formula for circumference is circumference equals 2 pi r. Whoops, I made a boo-boo there. It shouldn't be doctor. Let's fix that. It should be, let's write it in pink. It should be d pi. Okay, so we fixed that boo-boo. So let's ignore this over here. My mistake. Remember, I'm only human. Okay, now remember, let's talk about the radius. Radius starts at the center of a circle and extends to the outer edge. And radius is equal to half of the diameter. Now, if you think I'm going too fast, remember, you can pause this and write. The diameter, which equals d, goes to the center of the circle from one quote-unquote side through the center to the other side. Now, diameter is equal to 2 times the radius. So if the radius is 5, the diameter will be 10. Okay? If the diameter is 28, the radius will be 14. And here's a picture to kind of show you what I'm talking about. See how the diameter goes from one edge through the center to the other edge, while the radius starts at the center of the circle to the edge. So there's a little review for you. Okay. Now, over here we have a circle, and it has two angles that have the same name, BCH. Okay, we have little BCH and big BCH, which is turquoise. And also make sure that you know that total degrees of a circle equals 360. So now this symbolizes that these are two central angles of this circle. And remember, the vertex is at the center of the circle, so you can see where it changes directions. We go zip, zip, okay? And as I said, in this diagram, we have two central angles. We have a small one and a large one. And if I took this pink angle and I added it to this large angle, I would get 360 degrees, okay? Which is what I stated right there, okay? Now, a central angle measure, let me make this easier for you, is expressed in degrees. An arc length measure is expressed in radians. And so the arc is right here. We have minor arc BH because it's little, and then we have major arc BH because it's big. Major, big, minor, small. Normally we express major arcs with 3 letters, but I don't have another point on here, so I can add one right now. And we'll call it M. So then it would be major arc BMH or major arc HMB. But minor arcs are always with 2 letters. Okay? So now we're going to talk about the formula for arc length, which is as follows. Okay, there it is. There is the formula for arc length, which is the central angle over 360 degrees is equal to the arc length over 2 pi r. Now notice that this is the total degree of a circle, and this is the part of a circle. An arc length is dependent upon whatever the radius is. And notice that this is the formula for circumference, okay? Now notice the formula is expressed in terms of r, which is super important. And then when we look at example 2, you'll see what I'm talking about. Okay, example 1. Find the arc length of a circle when the radius is 3 centimeters and the central angle is 60 degrees. Okay, so we're going to substitute the values into the formula and we'll have arc length equal x. Okay, so here we substituted the values. There's a central angle because it said it was 60. And the 360 doesn't change. Arc length went to x, and then we substituted r because it said the radius is 3, and we substituted the 3. So now we're going to simplify our values. Now we can reduce this fraction to 1 over 6. So then I multiplied the 2 to the 3, and now I have 1/6 is equal to x over 6 pi. So now we're going to cross multiply. And then we get 6 pi equals 6x, and do some simple algebra, divide both sides by 6. And we find that for this particular circle with a radius of 3 and a central angle of 60, that this arc length is equal to pi. One last example. Okay. Let's find the measure of the arc length when the diameter is 20 centimeters and the central angle is 216. Okay, so once again, let's substitute the values. Okay. Okay, so I have the central angle is 216 over 360. And then we have x over 2 pi, and the radius is 10. Now remember, they said the diameter is 20. So remember that the radius is half of the diameter. So now let's cross multiply. And we get 360x equals 4,220. And I'm doing it this way to see, let's say that I don't know if this reduces, but it does because 216 is an even number, 360 is an even number. Okay, divide both sides by 360, and we find that the arc length is 2 pi radians. So that is arc length. I'm going to be doing another video on sector area. If you want another example of this, please send me a message through Remind. Okay? Have a great day. See you soon.